Hey guys, and welcome to Chem Squad Chemistry. Today, this is Mr. Mullins. We're going to be talking about covalent bonding and how to name a covalent compound. So hopefully you've already watched the organic compound video and you've done some practice with that and you're ready for the next type of naming. Remember, there are four that you're going to have to be able to tell the difference between. We have our organic, our covalent, our acids, and our ionic. This is just simply number 2. So we are going to be in our book today on page 1, 2, and 3. There are a few notes there as well as some practice problems. If you've not already familiarized yourself with page 2 and the vocabulary at the top, you should familiarize yourself with that now before continuing. Alright, so for covalent bonds, there are also a set of prefixes that we have to learn. These are more of the traditional prefixes that you should probably already know, where 1 is mono, 2 is di, 3 is tri, 4 is tetra, and then from here on out it's the same as it was with organic. We have 6 being hexa, 7 being hepta, 8, you guessed it, is octa, 9 is non, and 10 is deca. So these are a little different than they were with the organic, but really the biggest difference is 1 through 4, where you have mono, di, tri, and tetra. So go ahead, and we're going to be using these prefixes. Don't get them mixed up with your with your organic prefixes, or you'll immediately be getting the problem wrong. So the first thing you always want to do when you're starting to name a compound is to first identify what type of compound it is. As you know, we're going to be having 4 different types of compounds we're going to be naming. You need to learn to tell the difference between the 4 of them. I'm going to go ahead and show you a little example of all 4 of them, where here we have C2H4. You should recognize that as a hydrocarbon, and you would be using your organic rules for that. We know that covalent bonds happen between 2 nonmetals, so something like carbon and oxygen. You should recognize that as a covalent, and we're going to be using the covalent names for that. We also have ionic bonds, something that looks like LiCl, which is a metal and a nonmetal. You would recognize that as ionic. And then lastly, we have acids, which would be something like H2SO4, which start with hydrogen. So you've got to tell the 4 things of these different. So the first thing you always want to do is identify the type of bond. That seems pretty simple, but you just always want to make sure you're following the correct rules. Otherwise, you're just going to get off on the wrong foot. So always identify the type of bond first. And then it's going to be very simple from there. So over here to the right, we notice that one of them is a covalent bond. We are going to try to name that. Hopefully you already know the name of this one, but we're going to prove to you why it exists that way. So step 2, you want to write the name of the first element in the compound. So in this case, we have CO2, where C is our first element. So we're going to literally just write its name, carbon. If you don't know it, use your periodic table to find its name. If there is more than one of the first element, you must use a prefix. But because there is only one carbon here, we are not going to put mono in front of it. Let's look at another example. If we have N2S4. Again, this is a covalent bond. We know because nitrogen and sulfur are both nonmetals. We see that nitrogen is the first one, so we're going to write nitrogen. Because there are 2 nitrogens, more than one, we have to use a prefix to denote how many there are. In this case, what means 2? The prefix di. So the correct thing to write would be dinitrogen. So step 2 is super easy. You're just going to write the name of the first element. If there's more than one, you're going to use a prefix to tell you how many there are. All right, so step 3 when naming these molecules is is going to have to do with the second element. So in this case down here, we decided that carbon was the name of the first element. The second element is oxygen, O, clearly, but we see that there are two oxygens, so we need to denote that with a prefix. Always, 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 even if there's just one, choose a prefix for the second element. So in this case, we have O2, so we're going to put dioxygen. You're also going to notice that there is an additional rule that goes along with this. The second element will always end in "ide." There are going to be multiple endings that we are learning this unit that tell us a lot about these compounds. "Ide" is the first one. It tells us that the element is monoatomic. Let's break that word down. Monoatomic means that it is one atom. So more specifically, it's one type of atom. We see here that in CO2, oxygen is the only atom. There's one atom there. So we're going to end, instead of saying oxygen, we're going to call it oxide. So carbon dioxide. Over here, we decided that this was dinitrogen from step 2. We see that this is sulfur, but because it's one type of atom here, it is a monoatomic. It needs to end in "ide," so we're going to call that sulfide. And we see that there are 4 of them. Does anybody know the prefix for 4?
Why?
Tetra. Good try, though. It's tetra. So tetra would be the prefix that goes there. So our answer here would be dinitrogen tetrasulfide. On the next slide, we're going to do a few practice problems. We are going to be working on page 3 of our book, 11 through 20. We're just going to name a few of these together until you get the hang of it. Number 11 is P4S5. Let's go ahead and name this. We recognize that it's a covalent bond because they're both nonmetals. The first step is to name the first element, which in this case is phosphorus. Phosphorus. We notice that there are 4 of them, so the prefix for 4 is tetra. That's right, tetra. Tetra. So tetraphosphorus. Notice that my first element never ends in "ide. Only the second element ends in "ide. My second element here is sulfur. It's a monoatomic, meaning there is one type of atom, just sulfur. So we're going to end that in sulfide. "Ide" tells me that's one type of atom. And there's 5 of them, so we're going to use the prefix penta. So my correct answer here would be tetraphosphorus pentasulfide. Now some of you may be confused. Well, if that's a monoatomic, if S5 is a monoatomic, what would be a polyatomic? Well, this would be a polyatomic. Sulfate. Sulfate. You notice how that ends in 8. 8 is telling us that there are oxygens there, a normal amount of oxygens, whereas here we just have sulfur. So because it's only sulfur, it ends in "ide." So you can see the difference between a monoatomic and a polyatomic simply has to do with, is there more than one type of atom there? All right, let's move on and try the next one, which is NO2 and SEF6. I'd like for you to go ahead and try these two, and then I'm going to give you the answers. Pause the video now and try them on your own. All right, let's go ahead and name these. Nitrogen would be our first element, so we would write nitrogen. There's only one of them, so we don't put mono in front of the first element. Next, we have oxygen, but because it's a monoatomic, we're going to call it oxide. And there's 2 of them, so it would be nitrogen dioxide. The next one, this is selenium. And because there's 6 fluorines, we're going to call them fluoride, and 6 is hexa. So selenium hexafluoride. One more that's not on your paper. Let's go ahead and do CO. We know that that is carbon and monoxide. So you notice how when oxygen is there only one of them, if it's the second element, it's going to get the mono. The first element never gets mono. All right, so our next step is when you are given the formula. That was us giving the formula and writing the name. So what happens when you're given the name and you want to write the formula? There are some rules that go along with this, and this doesn't really make sense right now, but after you learn how to do ionic naming, you're going to realize that a lot of people try to come back and use those rules here. So wherever you're taking your notes at, go ahead and write this down. Do not crisscross and do not reduce the subscripts, and that's really going to play a role later, but these are just two rules that a lot of people do. They break these rules all the time, and I just want you to go ahead and see it. So simply, we're going to be on page 3 at the top. We're going to be working backwards, starting with the name and writing the formula. So we have on page 3, number 1, looks like we have diphosphorus trioxide. Simply what we're going to do here is we see that we have phosphorus and oxide. Ide means it came from a monoatomic, which is oxygen. So we clearly have P and O. Di tells us there are 2 phosphoruses. Tri tells us there are 3 oxygens. So my answer would be P2O3. It's just that simple, using the words to go straight back to the formula. So here for number 2, we have carbon tetrabromide. Carbon tetrabromide, we know that carbon is C. Bromide came from bromine, which is Br. Tetra tells us there are 4 bromines. Since there is nothing written in front of carbon, we assume it's 1. So we would have C, Br, 4. Let's skip down a little bit and do a little harder one. Let's go to number 6 on page 2. We have dinitrogen trioxide. We know that nitrogen is N. Oxide came from oxygen, which is O. Di tells us there's 2 nitrogens. Tri tells us there's 3 oxygens. So N2O3. It's that simple. There's lots of practice in your book. You can work all the problems from page 3 through 4. And we will go over them in class. If you need any more help, please come see me or Miss Bobby. Chem Squad out.